Hi everyone. Hello. Let's work on a problem for my investments class. So basically, you'll be studying with me. So I'm gonna try to work this problem. Should be relatively straightforward. Stock XYZ has an expected return of 12% and a beta of 1, and stock ABC is expected to return 13% with a beta of 1.5. The market's expected return is 11% and the risk-free rate is 5%. According to the capital asset pricing model, which stock is the better buy and what's the alpha of each stock? So I'm going to write down a more simpler version of the CAP-M formula. That's what I call it. This is beta, and then we have market return minus risk-free rate. So that's the formula. And we already have the, obviously we're given risk-free rate, we're given the market return, it says right there, and the market risk premium, which actually, I'll read this, market risk premium is basically this in the formula. Just that. Risk-free rate. So, to give you guys an example, I have to move this. Excuse my dirty desk. You can see it here, this formula. It's basically this section. So, which is basically this section. So we're giving market return, that's 11% minus 5%, 6%. So let's do XYZ first. Actually, let me write it like this. Sorry if the camera shakes. You could write CAP-M XYZ, right? Risk-free rate 5% plus 1.0, because that's a beta here. And multiply that by, I guess we can write it like this, 11% minus 5%. Yeah. Like that. Okay, I got my financial calculator. The way it's solved for me, because I'm just kind of like how do I say this? Like re-solving this problem for myself, but it's already been solved for me. The way it's been worked out is that basically you take, this obviously is going to be 6%, so that'll just be 6%, because obviously 1 times 6 is 6. So 5 plus 6 equals 11%. So that's supposedly our answer. If I'm wrong, let me know. that's our answer so far for this talk first. And then we'll do the alpha because we are asked about the alphas as well. And that's pretty easy. We have expected return. Oops, return. Weird handwriting. And then kappa. I don't feel like writing all this out, but the required return, what we basically found here. That's pretty easy because remember that the expected return for XYZ is 12%. So that's 12% minus 11. And you get 1% is the alpha for that. So let's see, we'll have to do the second one too. And I don't know if you guys will be, yes, I'm using my magnesium vitamins to balance this out. Okay. Oh, you can see my hair. Brush, okay. So let's do cap F for A, B, C. So again, 5% plus the beta, which was right here. And then we're gonna do again, we're just writing it out, but we know that's gonna be 6%. That'll equal, again, following the same kind of vibe that we did here. Vibe, I don't know what to call it. Definitely not a finance bro. I'm just a student. Okay. %. Next, we do the alpha. So I'm running out of space here. I better. Is that a good ASMR sound? Okay. Alpha for ABC equals, I don't feel like writing this out, but we already know what we're going to do. Expect a return over the kappa we just found. And that's going to be, okay, 13% for ABC. Very simple. 13 minus 14. That gives us negative 1%. So that's interesting. So what we learned from this, I'm going to write here. X, Y, Z is the better buy. And why? Because what I am learning so far about alphas and stuff is that this is expected to generate 1% more return than what's required for its level of risk. So obviously this is a negative. So that's not good. It means it's going to underperform the required return, basically. So yeah, because I'm just gonna put EC, this is for myself, it's my notes. Yeah, basically because it's a positive alpha, and that's about it. I mean, I can go, I feel like writing it down, but you know, this is just, it's gonna underperform. I'll write that down. Will underperform. Yeah. This problem's already worked out, but I wanted to read through it because, again, I have to try to drill this into my head, right? And this is actually the second part of a textbook problem. Technically, I should have written this down first, but right here. The risk-free rate is 2%, and the expected return on the market portfolio is 10%. A firm considers a project with an estimated beta of 1.3. So what is the required rate of return on the project? And this is again the same formula written out, again required return, risk-free rate plus beta times market risk premium. And I have it written down here, like what we saw, wrote down right there. Market risk premium is basically the expected return minus the risk-free rate. And so we see here, expected return on market profit on the market, that's a keyword in the problem, 10% minus the risk-free rate. So it's pretty straightforward. And yeah, and then you just plug and chug in this aspect. Risk-free rate plus the beta plus market risk premium, you'll get 12.4%. And then the second part says if the internal rate of return is 13%, then what is project alpha? And again, alpha is pretty simple to compute. You take the IRR minus required rate of return, which we found here, or the CAPM if you want to say, which again, we kind of see the same pattern here. We're calculating for alpha, it's really simple. We get 0.6%. So yeah,